So this is a continuation of the intro notes to IR. So for this, again, you want to have the packet that we were highlighting before, highlighter, but then I also want you to print out or have the IR bands. I want to kind of talk about this a little bit in this video. So again, we are going to be looking at what we call the functional group region. Is going to be what we use this for. Okay. So if you go to the next page, okay, you will start to see some what we call IR Spectra, okay? So this is, again, what you're going to be seeing. So again, on the bottom is your wave number. This is percent transmittance. So what you see is a band that comes up and comes back down. So that means it's absorbing light and then light's going completely through it. So these are what we call bands, depending upon the resource that you see. So these are the bands that we're going to be looking at and seeing what range they are in. And so for each individual functional group, I have some bands that always show up. So if I always have like an OH, there's a particular peak that always shows up. If I have a C double bond O, that always shows up in a certain range depending upon what functional group it happens to be. So that is where we're going to be looking. So go back to the top of this page in particular, and let's highlight a couple things. So the portion of the spectrum where the percent transmittance drops to a low value, then rises back near to 100% is called a band, okay? So that's what we're gonna be looking at. So a band is associated with a particular vibration within the molecule. Now the width of the band is described as either broad or narrow, okay? So it depends, again, on how large the range of frequency it covers. So that is what's going to change how it behaves. So we have also strong versus medium versus weak, depending upon the depth, okay? So if I look at this spectra here, these here are pretty narrow bands, and this one would probably be a little bit more broader, depending upon what you're looking at. But what is unique about the IRs is it gives you some idea on what functional groups you have. So a couple examples, hexane is C6H14, okay? And the IR spectra has a relatively few bands because there's only a CH bonds, okay? So because you are limited by that. But there is a unique CH stretch, which is around 3,000 inverse centimeters, okay? And so that is what this stretch is here over here on the left. So when you are looking at CH stretches, you will see that they are somewhere below 3,000, and they always show up in the same exact space. If you start to have double bonds or triple bonds, you start to see that that band shows up north of or left of 3,000, and then this one is closer to 3,300. So that is an area that we are going to kind of look at. So those are more, this one's more of a medium, but these are called narrow. Down here, I would describe most of these as narrow bands, and it does go through, this one is 1 hexene. So you have a alkene stretch that shows up somewhere north of 3,000. So that is what they're trying to describe there. I have a couple other examples that are a little better. But go to the next page. I want to show you more of a broad peak. So go all the way down to that next page. This is an example of an alcohol, an OH bond. And this is the one stretch I seem to have remembered from organic chemistry many, many years ago, is called the OH stretch. Okay, and it always appears, okay, for alcohols in particular, it's always in the 3,000s. So alcohols are usually 32 to 35, but they are what we call a very broad peak, okay, a very broad peak. And that is always indicative of an OH bond. So that's at least an introduction into what we call IRs, okay?